Hello, welcome everybody. Welcome to another OWASP Dorset chapter meeting. So tonight we've got Nigel Kay doing a talk for us on defensive programming. So we've got a live demo to go into as well. But before we get started, I wanted to make a few announcements as well to everybody. So I'm going to be stepping down from the chapter leadership, and we're looking to recruit some new leaders in the chapter. So if any of you out there are interested, please contact either Mark, Alex, or myself, and we can help you understand what being a chapter leader is all about. So we'll be looking for things of helping us run the chapter, promoting events on social media, and organising sponsors for future events. So that'll be the type of tasks that you'd be involved in doing. But if you're curious and you'd like to take part, and you can also get a complimentary membership of OWASP for being a chapter leader. There's something to be aware of as well. So if you're interested, just reach out to us on social media or over email, and then we can get through you with the details. But it's you'll be joining a strong team, and there'll be plenty of events coming up as and when restrictions are lifted. So I don't know if Mark or Alex had any more to say on being a leader. You got any comments to add?
Well, thank you, Dan, firstly, because for founding the chapter in the first place. I think it's
okay.
a really big thanks, and everything that you've been doing for OWASP for the last few years. And if anyone's interested, please get in touch, and we'll tell you all the details and show you the ropes.
Yeah. Okay. So I don't have anything further to add. Thank you, Mark. Yeah, it's been good. Been good few years. We've done a good CTF, and we've had plenty of meetups. And I'm sure there'll be more to come. And I'll still come to the meetups and still join in, but I'm just not able to do the leadership part anymore. So without further ado, I think we'll hand over to Nigel. And we'll go into our talk on defensive programming.
All right, guys, I'm removing us from the stream, and Nigel, in a few seconds, the virtual floor is yours.
Lovely. My name is Nigel Kay, and I'm a full-stack software developer. Anyone who's attended the physical Dorset meetups may recognise me, and I'm glad to now have the opportunity to contribute back. So a little bit about my OWASP background. While I was at university, I was taking a module on forensic computing, and I decided to take it further and do my dissertation on cybersecurity. And I was recommended to study the OWASP Top 10 and do some work on that. So when I saw the Dorset chapter come up, I was extremely excited to get involved. So today I'm going to be giving a talk on defensive programming, and we're going to be having a look at a private web application built by myself. We're going to be highlighting some vulnerabilities, where and why these occur. And we're going to do this by looking at the code underneath. We're also going to look at changes to the code to help prevent these vulnerabilities. We're going to be doing a couple of basic vulnerabilities, all centered around a login page. Now, this is not going to be a comprehensive guide to hacking, nor will I be teaching you to code the next Amazon or Google. But I'm hoping that this is going to be fun and informative, and if anyone gets anything out of this session, then that's fantastic. I'd also like to make a very quick disclaimer that this application is built and owned by myself. Do not use any of the offensive techniques that you see me using today unless you have explicit permission or ownership to do so. Basically, please do not do anything illegal off the back of this. However, if you do find any of the defensive programming techniques useful, then please, by all means, implement them and make your web applications safer. So we're going to start by having a look at SQL injection attacks. And this is actually going to be my last slide before we move into the application and code. So we're going to be looking into what SQL is and how the exploit works. This way, when we get into the live application, everyone should have a better understanding about what is going on. So SQL, or Structured Query Language, is a query language which allows you to interact with databases. If we take the following simple example, we can read it as the following. Select columns from table where condition is equal to blank. So a more practical example, along the theme of a login page, we can read it as select all columns from the users table where the username is equal to blank and the password is equal to blank. Now, these blanks that I've just mentioned are where the user input would go. So the user entered value from the login form would go inside of these apostrophes here, and so on with the password. But this raises the question of what would happen if you were to enter an apostrophe as part of the username when signing in. So let's look at the next example. But first, I feel it's worth mentioning that double dashes in SQL are used to signify a comment. A comment being something that is not read by the computer and intended only for the programmers writing and reading it. So in this example, we can see that with the input of the string admin : ; the apostrophe in the user's input has ended this username query early. It has then commented out the rest of the query, as you can see here. This means it has fundamentally changed the meaning of the query that is being made to the database. It now reads, select all columns from the users table where the username is equal to admin. But that's it. The need for a password has been removed. Okay, so I feel that's enough theory now. Let's go and do this for real. So today we're going to be living the dream of every 12-year-old hacker, and we are going to be hacking the NSSA, the not so secure application. So let's explore this login page a little and see what it's doing. Try and enter a random username and try to log in. As we can see here, it needs a password in addition to a username for the request to be sent to the back end. And if we try the admin account that we've seen in the example previously and try to log in with a random password, it's not logging in. However, if we were to now use the example from before and enter admin apostrophe double dash and then enter anything we like in the password here, we can see that this now logs us in. We have just bypassed the authentication. So we're going to look at the code underneath now and see where this vulnerability has occurred. And I'd also like to quickly state that for the simplicity of this example and code readability and building of the application, password hashing has not been used, but there is no scenario in real life where you would not want to use password hashing. So if we look at the vulnerable root here, we can see that the query here, the vulnerability is that the user input has been directly concatenated into the query. Now, one of the first rules of building software is that you should never ever trust user input. We can see that the user's input is literally being concatenated into the query string, which is then run against the database. This means that in our example, our query commented out the condition of needing a password here, meaning that all the database was asked to do was return the data from the database where the username was equal to admin. So if we look just below here at the more secure version, we can see that the query has changed and we have now used parameterization. And this is the solution for this problem. Parameterization should be used instead of concatenation, and using the default methods of a library and parameterization is a much safer way to go because the user input is sanitized before being applied to the query. So if we were to now go back and visit our secure version, if we are to use the exact same attack, we will now see that the login has failed. This is because the user input was sanitized. So moving on, we're now going to be looking at a NoSQL attack. NoSQL is not only SQL. And the NoSQL database that I have used in today's example is MongoDB. The difference here between this and regular SQL is that MongoDB is a document-based database rather than being relational like SQL. MongoDB also uses BSON, which is binary JSON, to store and represent the data. NoSQL injection attacks can be more dangerous as there is no query language involved and instead uses the backend framework's language. In this project's example, that would be JavaScript. This means that a NoSQL attack can not only be run against the database, but can actually be run against the application itself. So this time, we're going to be using Burp Suite to catch and modify a request. So as we can see here, here is the request that I've made. And what we can do is we can change this using the not equals operator. And when we then forward that, we can see that it has again bypassed the authentication. Now, the reason here is the same as SQL. So if we now go and have a look here, we can see that once again, the user input has been used directly. No sanitization has been used. So the solution for this would be to use sanitization. And in this example, I have used a sanitization library, which is an out-of-the-box way to sanitize and protect yourself. So if we now, again, go back and have a look at the secured version, and use the exact same attack, then we will see this time that the attack has failed. Now, something else to draw your attention to here is this error message. This error message does not look like the kind of thing you want to be returning back to a user. And that leads me on really nicely to the next vulnerability, which is error messaging. So for this vulnerability, we're going to have a very quick play with this form and see what we can find. So if I enter some random data and try to log in, then we can see that the error message here says that the username does not exist. If we now try and use the admin account, which we've used previously, and try to log in, we can now see that the error message has changed. No longer is it saying that the username does not exist, but it's telling us that the password is incorrect. So this is a case of the developer being far too helpful and friendly and trying to hold the user's hand. Whereas in malicious hands, this is highlighting an account that exists, which can later be attacked. So if we are now to go and have a look at the code here, we can see that in this example, we check for a username, and if no username is found, then we immediately return and let the user know that. If this user does exist, then we then make the password check. If the password check fails, we go and tell them exactly that the password is wrong. If all of it's correct, then they are logged in. The problem here is that different error messages are being returned in different scenarios. So the better way to solve this would be to use standardized messages. So whether it's the username or the password that is incorrect, you want to return something generic. You don't want to give a definite answer. So here, for example, the error message is just please try again. And that is being used whether the password or the username is incorrect. So if we now go and have a look at this in action, then we can see with an account that doesn't exist, please try again. With an account that does exist, please try again. So for our fourth and final vulnerability area for today, we will be looking at brute force attacks. And this leads on really nicely from our previous vulnerability of error messaging. You may be wondering why finding out if an account exists or not is useful to an attacker. Well, when you know an account exists and there is no brute force prevention in place, then it may only be a matter of time before the account is compromised. So we're going to be using Burp Suite again, but this time we're going to be launching a brute force attack. And what we're going to do is try to send a request here. We're going to capture the request. We're going to send it to the intruder. We're going to do a cluster bomb attack. The first payload of the username. At the moment, we're only interested in one, so we'll just add admin to there. And for the second one, this will be the password list that is going to be iterated. So into here, I am going to paste a preloaded selection of passwords. And now we're going to start the attack. And you can let this run, and you'll see that now the attack is finished. And you can have a look down and see that there's a slight difference here. And looking at the response you get back, you can see that this has successfully logged us into the application, whereas the rest of the attempts fail. So let's have another look at the code here. So what was the vulnerability here? The vulnerability that nothing was stopping the attacker from repeatedly sending requests with different passwords in. So the solution here is to implement a brute force library. And in this example, I am using something called Express Brute. And this limits the requests being used by using the Fibonacci sequence, meaning that with every incorrect attempt, the length of time before another request can be made increases. This is all temporarily stored in the database with a timestamp for when the next request can be made, and also a timestamp for when the row of data will be removed from the database. So as you can see in the code here, it's got a few different configuration settings, but the main point here is that for this more secure route, we are passing in the prevention. Okay, so if we are to now run this attack once more on the solution, then then we will be able to see what it has done. So running the exact same attack, so as we can see here, the first request that was made was fine. And after that, each of the other attempts to the database have been throttled and stopped by the brute force prevention. So with the implementation of that, it not only can slow down the attacker, but also highlight the attack that's ongoing, and also temporarily stop the account from being attacked. So this concludes my talk for today. I'm happy to take any questions that may arise.
Thank you, Nigel. That's very informative. We haven't seen any questions come in yet, but we'll open it up, and we know there's a slight delay on the stream, so
Cool.
we'll have to wait for them to come through. So we'll have to sit tight for a bit. Yeah, hopefully you found that interesting, everybody. We did have a longer session planned, but unfortunately one of our speakers cancelled on us, and we've had to go ahead with just one talk. But it's still quite good to see. Good to see the use of Burp Suite there. And was that the community edition you were using, Nigel?
It is, yes.
Okay. Do you find it? Does everything you need it to?
Yeah. For what I've used it for, it's been great.
Okay. We've got a comment.
We have feedback.
Okay. Yeah.
Thank you.
Yes, we're waiting to see.
All right. Okay.
If you have a question,
Let's
yeah.
start.
So can you see that on the screen, Nigel?
Yes, I can. So have I used any of the OWASP cheat sheets? Yes, so I was working on a personal project recently using the same sort of technology stack that I used to build the example application today. And when I was building my personal application, I did use the OWASP cheat sheets to look at common security issues to make sure you're not falling down the same trap. And on the flip side, for the attacking techniques, I've also looked at the OWASP cheat sheets for the sort of user input and stuff you can look at to test the application.
Yeah, it's a really useful resource, actually, those cheat sheets.
Definitely.
Yeah.
Yeah,
Thanks
we
for
have
the question,
another one
Mike.
from Olga.
Okay, so for getting into defensive programming, so I feel like a really useful thing to consider when thinking about secure programming is to look at it from both sides of the equation. So not only do you think about what you're trying to build as the programmer, but you also want to take on the malicious mindset of an attacker. So when you build something and plan how you're going to do something, you also want to flip it around and think how you would then attack it. So it's almost like a game of cat and mouse between the defensive mindset and the attacking mindset to improve the application as best as you can. So I feel looking at resources for both programming, but also learning a bit about the offensive techniques is really useful for being defensively minded when programming.
Thank you. Question from me. How did you did you learn? How did you learn to do defensive programming? Is that something you self-taught, or did you attend a course? Something you picked up through your career?
So I am a self-taught coder, as it were. I learned through YouTube and Udemy. I then got a job as a software developer, and through working professionally, I've learned a lot of best practices, a lot of not only clean coding but secure coding techniques. And I would also say, as I covered on before, the OWASP cheat sheets, looking at what some of the common vulnerabilities are and things to consider. Using those resources were really useful, especially when I was trying to build my own web application.
Yeah, that's great. It's good to hear that the OWASP resources came in quite handy.
Absolutely.
Nigel, did you get a chance to participate in our secure coding challenge at the end of last year?
Yes, I did. So that was a really interesting one, actually. I took Node.js as my language, and I finished joint 11th in the end for the UK-wide tournament. So that was a lot of fun. And if we were to do something like that again, I would recommend that anyone watching takes part. Not only was it very enjoyable, but I definitely learned some things there as well.
That's good to hear.
Good to know it was useful.
Definitely, yeah.
Another question from me, Nigel, have you used any other boxes to practice, like Hack the Box or something like that?
Yeah, so when I was doing my university dissertation, I actually used Meetup too, and that's what I based my dissertation off of. And I've also used some of the other online ones. It's escaped me which one I've used in particular. But as far as actual like boxes go, I've not done a whole lot of that, but it's definitely something that I will look to do in the future as my own knowledge increases.
Right.
So we should say another resource for people on this is the DVWA, Damn Vulnerable Web Application, if people want to look into that.
And there's another one, actually a new project from OWASP. Is it Juice Bar?
Juice Box, isn't it? Yeah. Well, Juice Box. That's it, yeah.
Mm-hmm.
Yeah, I haven't had a look at it myself, but I've heard of it. That is quite good. Good results. Not seeing any more questions. I think we will look to wrap up. I don't know if anyone else has got any more questions. It's only a short session this evening. Alex and Mark, have you got any more?
No, I'm okay.
Okay.
This was a very good talk. Thank you, Nigel, first of all.
Thank you for having me, and thank you for all the sessions over the past, is it two or 3 years now?
Yeah, started in 2019. Yeah, it's been going for a while now. But yeah, I'm glad you've enjoyed them. That's good. Plenty more to come. Thank you for your talk, Nigel. It was very informative.
Thank you.
Yeah, thanks for choosing us as your first talk.
Yes, this is my first talk.
Okay.
Well done.
Congratulations on your first talk. Yeah.
Thank you. Yes, the live demo went okay.
Yeah, it did, didn't it?
That was a surprise.
Yeah. Just a comment from Mike. Thank you, Mike. Yes, appreciate it.
This is maybe the last comment we saw.
Yeah. It's not just me. There's a lot of effort from Mark and Alex as well. There's a joint effort between us all. And without Alex and Mark, I don't think the chapter would be where it is today. We wouldn't have had the events that we've had. So it's a combined team effort.
All right.
And wonderful speakers as well, like Nigel.
Yeah.
We couldn't do it without them.
Absolutely.
All right. Shall we call it a night then? Every night, 7:30. So
Yes.
thank you guys for being here today, and we'll see you in the next one. Good night. Good evening.
The next talk, everyone. Thank you. Bye-bye.
Cheers.
Thanks.